Okay, good morning. This presentation is co-authored with Professor Robert Warden, who says hi to everybody, and he's currently in Belize doing fieldwork as part of an ongoing project from the Center of Heritage Conservation at Texas A&M. Recognizing change as part of the process by which heritage is continuously transforming constitutes a key concern today. From a tangible perspective, efforts in heritage conservation focus on mitigating the effects of these uncertainties in the material by making use of advanced developments in technology, which are applied from the stages of recording, documenting, and monitoring all the way to stabilizing and repairing actions. The developments in preservation technology and complementary innovations in other disciplines, such as structural analysis and material science, as well as increasing capabilities in tools such as photogrammetry, 3D laser scanning, computer-aided design, etc., are providing an exponential growth in the amount and quality of the data that becomes available. Therefore, heritage sites constitutes a vessel that contains potential unlimited information and acts as a canal that connects past and future through a partial and limited but continuously evolving understanding of the present. The notion of change, then, is a key here as well. On one hand, changes in the social, economic, natural, and built environments that interact and affect heritage sites. On the other hand, changes in technology available that enhances our senses in order to understand this phenomena. The use of heritage sites as potential containers and canals of knowledge is therefore the role of preservation education, acting as an interface in order to understand the diverse dimensions of change. Each case study constitutes a potential database and is used to transmit the knowledge that from it is produced. However, this process that is traditionally a method in preservation education encounters challenges due precisely to the nature of the notion of change. Change is unstable and dynamic. Unforeseen relationships and interactions occur among tangible and intangible aspects in heritage. Therefore, any effort in preservation education must, in first place, recognize that preservation actions, as a design problem, also impact the heritage site. Therefore, on second place, an interface must be flexible and open enough as to incorporate and recognize new variables taking place. In other words, preservation education must be active in generating mechanisms to include through understanding the evolving consequences of change from diverse sources. This presentation aims to contribute towards understanding the role of current developments in documentation, recording, and monitoring technologies in the emerging efforts in preservation education towards managing change in heritage sites. The development of a preservation management model, for the Alamo Historic Mission in San Antonio, Texas, using cutting-edge documentation equipment and computer-aided design software by a team from the Center of Heritage Conservation at Texas A&M University in collaboration with our other institutions is presented. The Alamo San Antonio de Valero mission was established at the present site of San Antonio, Texas, by laying the cornerstone of the chapel in 1744. Founded for the purpose of Christianizing and educating Indian converts, the mission has a history of continuous changes. Its purpose as a mission began to wane after 1765 and was abandoned in 1793. In 1836, the siege and final assault on the Alamo constitute the most celebrated military engagement in Texas history. For many Americans and most Texans, the battle has become a symbol of patriotic sacrifice. After the fall of the Alamo, the building was practically in ruins. Other uses after the 1836 battle include its role as a U.S. Army Quartermaster Depot warehouse and eventually a memorial to Alamo defenders. These challenges in uses constitute the subsequent alterations on the material remains of the Alamo complex. More than 2.5 million people a year visit the Alamo complex, which houses exhibits on the Texas Revolution and Texas history. In its contemporary function as a heritage tourism destination, the Alamo is dedicated to educate all visitors, either online or in person, about the history of the Alamo and its importance to Texas and the nation. From a preservation perspective, the problem in the Alamo is multifaceted. The Alamo is a living, dying, changing structure, as all heritage is, that requires constant care and maintenance. Current conservation efforts are in charge with not only identifying the necessary maintenance required, but also in detailing historic questions that remain from the building. Over the last few years, the Alamo has hired conservator Pam Rosser to assess, conserve, and document the conditions of the historic buildings while overseeing long-term preservation projects. The assessment of the Alamo Church includes examination of the condition of the limestone, mortars, and plasters from the Spanish mission period to present. The process of registering this information is done by hand through detailed damage maps in order to identify and locate material and historic evidences on the fabric. Problems with this methodology are, on one hand, the possible loss of all this information due to the fragility of the media used to document, which is paper. On the other hand, the data register provides limited accessibility by other disciplines involved in preservation efforts simultaneously, as it is a very personalized record. Furthermore, the addition of subsequent information to the initial registries becomes problematic as the media is static and closed. Therefore, two challenges that can be observed are, on the one hand, the necessity to integrate the diverse and extensive amount of data that is produced within the Alamo as a case study, in order to make use of this information as knowledge for decision making. On the other hand, the transformation of knowledge into accessible resources for the diverse type of audiences related to the heritage site. In order to address these challenges, a team was formed composed by the Center for Heritage Conservation from Texas A&M University, Texas A&M University at Kingsville, the University of Texas at Austin, and the University of Texas at San Antonio. The overall concept proposed by this team was to develop and organize a digital repository of information that would be not tied to a particular software and be web-based in order to be accessed by diverse groups of people. The purpose is developing an online searchable database to help keep track of preservation work and maintenance issues currently in development. The Alamo Digital Database being proposed is inspired by digital databases that are capable of managing great amounts of data, linking diverse types of information, and are designed for easy access throughout a visual interface. One example is Google Earth. An application of the concept for a digital database is provided by the ARCHES project. The ARCHES is a new open source geospatial software system for cultural heritage inventory and management. In order to address the Alamo challenge, the CHC at Texas A&M University evaluated the idea of using ARCHES, considering its characteristics as a common platform, easy to use, customizable, and open source software system. Furthermore, its specific design to serve the heritage field seemed appropriate for the Alamo project. However, after an initial assessment, the team determined that ARCHES would not fit exactly the type of data handled for the Alamo due to the size and type of files obtained from the use of technologies such as the 3D laser scanner, the gigapan, photogrammetry, etc. Therefore, the team proposed developing a digital database system based on the ARCHES project, but made specific for the size and type of information handled. In the same way, Google Earth and ARCHES projects are systems with a database that is continually renovated and provides a visual interface for easy use. For the Alamo project, the same purpose was the goal, providing a friendly system for current preservation works to be documented in visual and text form. 3 levels of knowledge can be identified from the process developed for the Alamo project. The first level of knowledge refers to the data obtained through processes of documentation in the Alamo using different types of technologies and processes such as photography, 3D laser scanning, photogrammetry, etc. The second level of knowledge refers to the information obtained by integrating first-level data in the preservation management model proposed. The third level of knowledge refers to the information developed by understanding the Alamo Digital Database and the process by which it is made available as an open source that is transferable for new trends in preservation education. One of the sources available are drawings from the Historic American Building Survey HABS archive. The Center for Heritage Conservation is currently checking and adding information that is available today through the use of high-resolution photography. For example, overlapping photographs on current CAD software, drawing stone by stone In the facade, it's being done. One of the technologies used to obtain the high-resolution photographs and that enables zooming in and out without losing the quality of details is the gigapan. Gigapans are gigapixel programs, digital images with billions of pixels. They are huge panoramas with fascinating detail, all captured in the context of a single photo. From the panorama view of the west facade, zooming in the high-resolution image provides still high-quality details. The capability of zooming in and out without losing quality provides many uses for the database, such as documenting a visual inspection, using as a template to draw stone by stone for completing the existing HAPS drawings, or locating where mortar samples have been taken. The CHC leads the effort to create digital models to track erosion due to rainwater and the effects of temperature changes on the structure, reconstructing how the Alamo existed in three representative historical periods, 1836, 1885, and 1961. Digital models are being created using 3D SketchUp. 3D models obtained directly from documenting the existing complex are obtained through the use of photogrammetry and 3D laser scanning. A difference comparing the Alamo digital database from Google Earth is that the data from the building is collected as a complete entity with exterior and interior, therefore providing additional information such as the width of a wall. A challenge for the development of the database refers to the selection of how to present this information as 2D and 3D, provide each different benefits and complications. Until now, all information is being gathered in 3D, but is being presented in 2D, considering that the conservator is specifically interested in the wall plane. For future purposes, in the case of the west facade, the 3D information of the erosion in the surface would be available for monitoring purposes. The preservation management model for the Alamo, based on the concept of an open source digital database, provides in its vision a second level of knowledge due to its capabilities to integrate the data obtained from the diverse disciplines involved in current preservation projects in the site. The 2D and 3D highly detailed models currently in development are integrated with information regarding erosion due to rainwater and the effects of temperature changes on the structure. For the ongoing conservation works, the digital template will allow including observations from cleaning efflorescence, locating and characterizing discoveries from pieces of polychrome that date from different periods, graffiti, painted, carved, and scratched, plaster types and locations, paint types and locations, etc. These aspects are referred as a second level of knowledge due to the expanded opportunities for making integrations that provide new information. For example, for the mortar analysis being developed parallel to the models, locating and characterizing in the models within the digital database these findings enhances the capabilities of the information that is triangulated to recognize easier possible patterns in the material composition that might be related to other aspects registers, such as historical records of possible repointing, replacement of stone, etc. In the same way, thermal imaging simultaneously performed and located in the models within the database can be easily visualized as providing information about water penetration issues that can be connected as well to changes made on the wall, such as an infill that is invisible to the naked eye. The possibilities of an endless triangulation of information and visibility of connections becomes available. Finally, the system provides a link between past, present, and future. A baseline is set with the current state, and the 2D and 3D models linked with continuously updated data becomes an ongoing database to add on and track the behavior of material and structure, as well as allowing to include future discoveries. Even simulations can be developed in order to speculate about the future by modifying parameters. As a third level of knowledge, I refer to the way in which technology, through its subsequent levels of transformation of data, contributes towards developing new trends in preservation education. A new paradigm currently in development that focuses on the capacity of systems to respond, recover, and bounce back from impacts is the notion of resilience. As has been the case for other disciplines, such as disaster management, mental health, and recently in urban planning, this concept can provide insights for historic preservation in the concern for managing change. The vision of a preservation management model for the Alamo contributes with understanding change in this heritage site, but it is the role of preservation education to situate this endeavor within overall changes in knowledge. Technology topics in preservation education have traditionally been linked to developments in science, technology, engineering, and mathematics-related disciplines. However, the rapidly emerging topics of high complexity, such as structural analysis, energy simulation, building information modeling, etc., is pushing towards higher levels of specialization within preservation education. The preservation management model in the Alamo suggests a complementary approach in preservation education, enhancing the capabilities of zooming in and out the process for understanding heritage in order to promote integration as a means to remind how the site as a whole is the purpose of the details. Following the same logic is the case of the links between preservation education and social sciences. Despite the technological-oriented nature of the preservation management model for the Alamo, the capabilities of the system to reach increasing amount of public generates an opportunity for preservation education to increase its role in promoting awareness for the value of this heritage site and to interpret the feedback from its users. Disciplines such as tourism studies and sociology are continuously providing insights by considering the relationships between heritage and society. Furthermore, keeping in mind the contemporary role of the Alamo as a tourism destination visited by more than 2.5 million people a year becomes a baseline for the education impact of the site and the importance of updated information that obliges reinterpretations of the past. A digital model, as an open source, provides the capabilities for tracking and understanding the causes and consequences of the technology we use and the design decisions we make through preservation approaches and its role in society. In other words, it is a reminder for preservation education to include asking why we do what we do, in addition to how we do it. Science, technology, and society studies recognizes that technology and design are eventually capable of doing anything. However, the question that must be asked before is, should we, as an ethical dimension? The vision in the future for the preservation management model to become a web-based resource for open access to the public transforms this peer-controlled database into an interactive interface where unforeseen relationships can develop. In a formal sense, open access refers to unrestricted online access to peer-reviewed scholarly research. The digital Alamo database open to the public, not only for transmitting knowledge, but as a receptacle of feedback, enhances the capabilities of including new links in the way Google Earth pins locations that become hyperlinks to external resources. Once the system becomes robust enough, from an education perspective, this resource can be used directly as a case study open courseware. Open courseware, in a formal sense, are course lessons created at universities and published free via the internet. Finally, it is important to acknowledge that databases have been around forever. A personal checkbook, accountants keeping records, etc. However, as soon as databases become complex, the issues for easily visualizing information becomes a challenge. An analogy can be that of the binary system, 0 to 1, that illustrates the infinity of data and the complexity of things. A building is not the universe, but it contains almost infinite amount of information in its complexity. Anything can be zoomed in or out indefinitely. Each level of zooming in or out has infinite information that can be attached or linked to it. When the challenge for managing change in the Alamo by keeping track of the data obtained through simultaneous preservation projects in development was required a solution by the Texas General Land Office, the argument used by the team was using academic institutions for the development of a system that could be innovative and redundant. Innovative in the sense of a long-term vision for investigating different aspects, and redundant in the sense of being careful enough to check what is done and how it is done. In other words, assuming an education and research role rather than acting as a business model consultant. The link between technology and preservation education is therefore the base that underlies the vision of the ALAMO project. New developments in technology and new trends in preservation education inform each other in this ongoing case study. This interaction inspires crossing traditional disciplinary boundaries, promoting integrations, and searching for new links. Thank you.